Hello, my name is Ron Littman and I'm going to talk about our work LaTr, Layout-Aware Transformer for Syntax VQA. ST-VQA is simply a VQA task in which the questions can only be answered by reading the text within the image. In row A, representative samples from text VQA are shown, where in row B we visualize the information extracted by the OCR system, showing that some questions only require text features. Some require both text and layout information, and only some need to go beyond that. Accounting for that, we propose a layout-aware pre-training and architecture. LaTr is made out of three building blocks. First, a language model which is pre-trained on only text. Second, the usage of spatial embedding tokens for the OCR bounding box in conjunction with further layout-aware pre-training on documents. And finally, a VIT architecture for obtaining visual features. Let's go over our method piece by piece. We base our LaTr architecture on the encoder-decoder T5 model. However, to account for the layout information, we want to create better alignment between the layout information and the semantic representations. We do so by adding the spatial locations of the text in the image and perform a layout-aware pre-training. We show that applying our pre-training scheme on scanned documents has certain advantages over using natural images, despite the domain gap. Scanned documents are easy to procure, text-dense, and have a variety of layouts, helping the model learn a various sample of spatial cues by tying together language and layout information. We perform a layout-aware denoising pre-training task, which includes the 2D spatial embeddings. Unlike the normal denoising task, we also give the model access to the rough location of the mask tokens, which encourages the models to fully utilize the layout information when completing this pre-training task. In fine-tuning, we add visual features from a VIT architecture, thus eliminating the need for an external object detector. And again, this is our final model. Now, let's look at some results. LaTr achieves a state-of-the-art performance with a margin of almost 8% on the test set. Similar trends appear on the ST-VQA and OCR VQA datasets. Now, let's dive deep and understand what is happening. To get a better sense of the biases in this task, we show that we can already achieve state-of-the-art performance on a visual question and answering task without any visual features. In fact, adding visual features only marginally increases performance. Recently, it was also shown that this phenomena holds true for the M4C architecture, where visual information only slightly contributed to the performance, validating that this is not specific to our technique. So, is vision an artifact in the task of ST-VQA? We present a concern on a dataset bias. To better explore the bias perspective in our work, we visualize question-image pairs sorted by the information required to answer them. This leads us to wonder, are visual features even needed for ST-VQA? Or, better yet, is vision an artifact in this task? We believe that visual features are of importance for the task. However, current benchmarks do not reflect it, making it harder to evaluate how much V matters in ST-VQA. The first category consists of all questions that can be answered with just an orderless bag of words. The second category consists of questions which require an ordered bag of words. The next category requires to reason over both words token and their 2D spatial layouts. The last category consists of questions which require reasoning over all modalities, specifically the text, the layout, and the image itself. Generating such questions is not an easy task, and therefore current benchmarks do not contain much questions like these. We convey a couple of important take-home messages for the ST-VQA community. First, language and layout are essential. Language indirectly is utilized for questions that need word or prior knowledge, or simply for language understanding. Layout information allows the model to reason over spatial relationships. In our work, we methodically demonstrated their importance to ST-VQA. Secondly, we propose the layout-aware pre-training and show a new symbiosis between scanned documents and syntax. Last but not least, we diagnose a condition in which ST-VQA models, ours included, make use of the visual features marginally. This begs the questions whether this is because of a dataset bias, and we, as a community, need to make V matter again in VQA? Thank you for listening.